Hi everyone, today we're speaking with Justin Lemmon, co-founder of LOHUM. So LOHUM is a battery solutions company that is present across lithium-ion battery value chain. So Justin, great to have you. For our viewers, could you briefly share what all does LOHUM do in the LIB space?
Hi, Priyakshi. It's an absolute pleasure to be with you. Thanks for your time. At LOHUM, we develop technology to make batteries last as long as possible. And then when they have no useful remaining life, then we recycle those. So our technology includes battery manufacturing in both first life and second life. And then when they have no useful life, we recycle the batteries to recover all of the chemicals and metals such as lithium, cobalt, nickel, graphite, etc.
Okay. And could you also tell us about the current scale of operations and your geographical footprint?
Sure. So right now we both across the manufacturing division and the recycling division, we have 400 megawatts of capacity between those two divisions, and then we are in the process of growing significantly both in India and then with our first plant overseas in the US.
Okay. And India, where exactly are you present? This 400 gigawatt hours capacity plant?
So we're in Noida right now. Currently, that's where all our facilities are located in Noida.
And this capacity is for recycling or for battery manufacturing?
That's a combine between both battery manufacturing and recycling. Split about 50-50.
With 50-50, right? So within lithium-ion batteries, what all kind of batteries do you accept for recycling? What all chemistries?
Sure. When we started out, we knew that there were already multiple chemistries and multiple form factors. We designed the technology to be as flexible as possible from input feedstock side. So we can take all batteries, lithium-ion, nickel metal hydride, and LFP, regardless of, and also the form factor as well. So from a cell standpoint, prismatic, cylindrical, and pouch.
Okay, and what is your collection mechanism? How do you go about collecting the feedstock?
So we have a varied amount of sources because just as you well might imagine, batteries are everywhere. You have them in the consumer electronic industry, you have the storage industry, you have EVs, and all those spaces are growing significantly. Our primary sources, however, are OEMs and aggregators.
So when you say OEMs, so you are getting batteries that have been used in electric vehicles like two-wheelers and three-wheelers? They're already coming out?
Not so it depends on the geography, right? So there's always going to be some, whether it's due to a maintenance issue or there's maybe a couple of cells bad, so the module goes bad, or perhaps there's an incident where the battery gets damaged, for example. So there's always a certain amount of feedstocks that's coming through. And then on the larger OEM side, you have excess inventory or excess production when they change from one design to the next. So there are a number of different feedstock sources. We try and take advantage of all of them, and then and develop longer term contracts from a feedstock supply.
Right. And apart from the EVs, you get batteries from electronics, laptops, mobiles, and so on?
Yes, we do get some from consumer electronics just because that is a useful, primarily right now, it's a useful feedstock stream, but our capabilities are designed for where things are going. So our focus primarily is on everything that's related to EVs and stationary storage.
Okay, so can you walk us through the process? Once you have the feedstock, what are the next steps?
So once we get the feedstock in, depends on what we get, varied types of feedstock. So it could be just cells, so battery cells. In that case, we can just test them, and then you get varied types of either a full battery or a module, right? Our process is that whatever feedstock has come into our facility, then we will dismantle it, and that allows us to test either at the module level or down to the cell level as well. What that testing process is essentially a window into what's the remaining useful life. And that's really the first step in our process of determining, can we reuse this module or cell in a different application? If we can, then we will either take that module, and maybe we need to add a BMS, for example, or something like that. If it's just a cell and we take the module down to the cells, then we will essentially rebuild a new battery with the used cells combined with all the other components that would go into batteries, such as BMS, electrical cables, et cetera, et cetera. And then if during that process, testing wise, they don't meet our criteria in order to be used for Second Life. And the key part about Second Life also with our process is that we guarantee a warranty. And so that's a critical part of us understanding from the testing standpoint, combined with all of our historical data based on years of testing and years of operation in the field. We sort of holistically look at that puzzle so that we can be very confident that once we build this Second Life battery and we put it into a new application, whether it's mobility or stationary, that it will last as long as we say it will. Yeah. The last part is if for some reason that testing does not meet our criteria, then that's when we will send those that feedstock to recycling. And it will enter our recycling process and then go through an extraction process where we recover all the battery materials.
Okay, right. And both physical separation and chemical separation are done at your Noida facility?
Correct, correct. We have a two-stage, essentially you can think of it as two-stage process. So it's a mechanical separation process combined with a hydrometallurgy chemical process. So on the front end, on the mechanical process, essentially we are shredding the battery to separate the electrode material from the non-electrode material. Mm-hmm. Once it goes through that phase, then it goes into the hydrometallurgy phase, where essentially we're using a chemical process to produce output that includes sulfates such as nickel sulfate, cobalt sulfate, manganese sulfate, lithium carbonate, and super high purity graphite.
Okay. And once these raw materials are obtained again, what happens next? So I'm trying to go through the whole value chain from collection to processing. So what next? Who are the customers who in India or abroad you are selling these materials to?
So most of what we're selling now into is back into the battery ecosystem. And that could be, there's a number of companies, particularly overseas, whether it's in Asia or Europe for that matter. But right now it's primarily focused on Asia, where we sell our output product, right? There are obviously outside of the battery ecosystem, large other industrial applications for chemicals and metals such as cobalt, nickel, and lithium, and graphite for that matter as well.
LFP is gaining a lot of traction, specifically in mobility space as well. So what we understand is it's economically challenging to recycle LFP batteries because the end products are not as valuable in terms of their monetary value. So I want to collect your thoughts on it. Is LFP battery, can that be economically attractive as well?
Yeah, it can be. I would say that right now the preferred recycling option is certainly the other chemistries. They're much more valuable. Anything that's nickel based is much more valuable. I think over time, just based on the amount of LFPs that are being generated, both in the mobility and the storage space, there will continue to be a greater focus on recycling those types of chemistries. But I think right now, primarily everyone's focused on nickel based chemistries just because the value is there. And essentially the other part of that is not only the value, but the demand in the sense of whether it's nickel, lithium, cobalt, those things are much more difficult to find. So they have a higher, greater demand.
Right. And Justin, what are your plans going forward in next 1 to 2 years? How do you plan to expand your capacity or your presence geographically?
So it's a twofold approach in the sense of we are expanding significantly with our India footprint. So we will be expanding to a 3 gigawatt facility that will be a combination of 1 gigawatt on the battery manufacturing side and 2 gigawatts on the recycling side. Outside of India, which will be expanding significantly, India is essentially our Asian hub. That's sort of how we think about it longer term. In conjunction with that expansion, we're also expanding overseas. So we have a lot of customers outside of India anyway, and both the US and Europe are very large markets where there's a high demand for Second Life, but a significant demand for recycling technology. And so we are in the planning stages now, and we will build our first plant in the US next year.
Okay. Like you said, there are a lot of nuances when it comes to chemical separation that can make a lot of difference to the final output and the overall process. What is it that makes your hydrometallurgy process different from what others might be using?
Sure. So if I would start at a sort of a high level, so you have the cathode materials, which is primarily nickel, cobalt, lithium, manganese, etc. And then typically on the anode side, you have graphite. Ideally, you want to, with recycling, you're looking at yield from how much material can you recover, and you're targeting at least 95% or above from a yield standpoint. Once you get that yield, then it's quality of output, right? That's sort of the next benchmark. And so most people at this point are producing what's called a black mass, which is essentially where they've separated the electrode material, but it's just a collection, if you will, of that electrode material, right? It's not separated. And so that's sort of the first type of output that across the globe most people have the capability of doing. The goal is, and what we do is individual separation on the output side, right? So separating the sulfate, so nickel sulfate from cobalt sulfate, right? And then you have the lithium carbonate, and then you also have high purity graphite. The goal is highest yield combined with highest quality of output that is individually separated. That is the absolute goal. Where you essentially are taking the processing as far as it can go before it goes into precursor materials for cathode material.
Okay, so in terms of yield, what would be the percentage that you achieve?
So we're at 95%. Okay. On everything, right? So across both the cathode and the anode.
All right. Okay. So I think that's all the questions we had, Justin. Thank you so much for answering those. And it was a pleasure talking to you.
Yes, thank you so much, Prakshi.
Thank you.